So we know that 2, 4, and 6 are even. So let's count the tallies. We have 5 here, 10, 15, 20, 24, 25, 30. So we know we have 30 total tallies on the evens. So how do I make the fraction? Ryan?
30 out of 52.
I have to think about the total, and I know the total up here is 52 tallies. So this would be 30 out of 52 as a fraction. What is the percent, of a 5 being spun experimentally? So experimentally means, what were the results? Got a few hands. Oh, there's a few more. Carl?
I got 12%.
How'd you do it?
So I counted the 5s, and there's 6 5s. So you do 6 over 52, and then you divide it like 11.
11.5, right?
Yeah, and then I rounded it up.
Yep. So you get 11.5% experimentally. We're not talking about theoretically, we're talking about in the experiment, what were the chances of getting a 5? Which number is most likely to be spun theoretically? In theory, if I'm using this spinner, I have these 8 numbers. What number am I going to get the most?
7.
All of them.
Theoretically, wouldn't it be no number because it's not like some are like that big and others are really big?
That's correct. Theoretically, this is broken into 8ths, the spinner. I have the same chance to get every single one of these numbers. One doesn't have more probability than the other, theoretically. Now, that's not how it worked out when they were spinning, but in theory, I should get roughly the same amount for each one. What is the experimental probability of a number being odd? Now, you can't just flip this. Because remember, 0 is neither odd nor even. So I actually have to go and count. So here I have 5, 10, 15, 16, 17, 18, 19, 20. So between 1, 3, 5, and 7, I have 20. That would make that a 20 over 52. So what's my probability? 20 over 52?
38%.
What is it, Radonna?
38%.
38%. And then how many trials were completed? Dude, if you don't do this now, you can turn every time. Ryan? 52 trials. And we already said that right at the very beginning. So, experimentally, you can work on you can figure out probability by doing an experiment. And then theoretically, that's just in theory, you have to look at how many choices you have and what are the outcomes you're looking at. We've started a new quarter. Last quarter is closed and over, and we're moving on. That was the best quarter of all the quarters I've taught of average grades, which is pretty impressive, guys, because, yeah, so that's really good. So I feel like you guys can even do a better job on this quarter because I don't feel like the material is as difficult as the moving straight ahead material. Yeah?
So didn't you say that last unit was like the hardest unit out of the whole year?
Yeah, and we didn't do very well. We got our lowest score, right, on investigation 3. And then on the unit test, you guys got a B average, which is like amazing. On the computer part, and then on the handwritten part, you guys had an 86 average. That's awesome. Because I felt like that handwritten part was easier than the computer, but I didn't think it was that much easier. But you guys just did so good on both of them, which is awesome. Today we're looking at how you can predict with accuracy, okay, so you have a chance to win. It's kind of like basically reading probability. You guys ever heard of people in Las Vegas who count cards?
Yeah.
Okay. You ever seen the movie Rain Man?
Yeah, I love
Okay. Rain Man is a classic movie. He's a card counter, right? He counts cards. You're not allowed to do those things, but he is called, it's an idiot savant, right? Is that the appropriate term? He is a mathematical, like, genius around probability. And there are people out there that are like this, like Rain Man. They can literally, over the course of hours and hours and hours, keep track of how many diamonds were played, how many kings were played. Not only that, like how many spades of kings were played. Like, and they can calculate all the cards and all the math, like just like that. So what they're doing, what Rain Man does, is he does this. He predicts with accuracy what cards are going to come up so he can win. And we're going to do that with the game. But before we get to the game, we have about 8 minutes. So we were going to do a fishbowl, but I realized it's not enough time. So I need everyone to get their reflections out. And remember, if you didn't do your reflection, don't sweat it. I'm going to give you a blank copy tomorrow, and you're going to do it during, because you're not doing it now. Okay? You're going to do it during your time. No, that's fine. Yeah, you have it. You should grab it. All right. So, what's yours?
I had it, but I think it's at home. It's done.
Tomorrow. Nope, it's not done. You're going to have to do it tomorrow during lunch. Not doing that anymore. You forget it, you come in at lunch, and you do it at lunch. You'll get a blank one. But the good news is you'll have it all planned out, so it should not take very long. You have yours? No. Yeah.
Can I do it like tonight?
You can work on yours during class. I'll take yours in class because you guys weren't here. You have yours?
I don't have my stuff, but
Okay. We'll do it tomorrow at lunch. Remember, don't even bother starting it now. You'll do the whole thing.
I know. But what if I bring it in?
Nope. 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 All right. I'm taking class time to do it. So this is what I'd like you to do. You're going to find a partner, okay, that works well, not a friend. Make sure we're clear on that. It's not like, oh, this person's my friend. I'm going to go. I want a good partner, and I want you to review, share, and review the mathematical parts of the rubric. You're not just listening to what they're saying. You're saying, okay, did you restate the question? Ask them that. And they say, yep, I did this. Did you use mathematical vocabulary? Yes, I did this. So it's not like I'm going to read you my response. I'm going to ask you, did you restate the question? And then you read it to me. Perfect. Did you use mathematical vocabulary? Perfect. That's the kind of sharing I want. Not, okay, this is what I wrote. I want one person to ask questions about the mathematical rubric, which is at the top, and the other person to answer. Questions? Okay, you may stand up. Cyrus and Rachel, come up to the carpet. You guys can kind of plan out how to answer these questions. Carl, you can start working on it, same as you, Quinn. You weren't here. It's closed. I put those grades in. Okay. Good. I like that way better. It's easier on me, better for you. I love it, Rachel.
I was doing it in intervention, and I put it in my intervention tab, and I could not find it. I was like, quick, no.
Find a partner. Go with Rachel. Come on.
How'd you research?
Side, put your chair down.
Well, what they said is that fighting
What was your, okay, so for the first one,
Who are you working with, Allie?
no one else has their reflection.
Go with these two. Ask questions, guys. Remember, you're asking questions.
And calculating the probability within that test.
I said you find
Okay, what question did you ask him?
If I answered all parts of the
Oh, okay. Okay, good. Your eye looks swollen.
maybe I can't even see.
This side.
What is glasses?
That one, right there, that one. Can I poke it?
No. He pokes it up my aura.
Yes, let me poke it.
No, you're not going to dig out my eyes.
Oh, Jane, I like you way too much.
I just like no, I have. And then
Remember to make improvements. I've already seen a few kids like, oh, I forgot to do that.
kind of hurt now.
And then my the second part like this kind of to give like an example, but I where there are two trials, I probably the left side and the right side.
And I use trials.
I did a table of oil and drew an arrow down.
Yeah.
To represent the length of the table down.
Sorry, next one you can stand the rest of the time.
How did you say we
Okay, yeah. Well, I said that one. They're both good. I
feel I said 500 results. 500 were better because there's more
No, how?
based on the trial. Well, actually, you have more data.
said,
It came out more accurate. Figure out. And then you can put all the yeah, that's what I'm doing.
I said
Okay, we have about 1 more minute.
and then everything works.
Okay, remember you're going to be, if you are finished, I am collecting those. Remember, I'm not taking any late ones. Because this is getting too much for me. You can pass yours in, right? I've got you marked now. Okay, I need all of the reflections to me. Thank you, Sylvie. No name.
Jay.
Thank you. No name.
Of course not.
Yes.
Thank you.
Thank you for reminding that I didn't have a name.
Thank you. Name. Bingo. Okay. Carl, you can put that away. Quinn, put that away, please. All right. So today, please get out this piece of paper.
Did you get the video to work?
Yeah. It's so corny, that's why I have to play it.
You're right. Everyone wins. Every member of our audience will get a chance to play this game. Here are the rules of the game. Contestants choose a block at random from this bucket containing an unknown number of red, yellow, and blue blocks. Each block has the same size and shape. Before choosing, each contestant predicts the color of his or her block. If the prediction is correct, the contestant wins! After each selection, the block is put back into the bucket, and the bucket is given a good shake to mix the blocks up again. Has everyone got that? We'll start with our first 3 contestants from the audience. Are you ready to play? Gee whiz, everyone wins! What an unusual costume! What's up with the cracker in your birdcage?
My parrot.
Well, what do you think his name is?
His parrot died in the cracker cellar. Cracker.
She sounds like the lady on
Polly.
Is it Polly?
Flew away.
So, what are you?
Polygon.
Polygon! That's terrific! Mix up the blocks.
Terrific.
Do you know what to do?
I sure do. I'm going to make a prediction, and then I'm going to choose a block and hope I'm right.
That's right. And if you are correct, you win. Now, what's your prediction?
All right. So that's what we're going to do. We're going to play this game. All right.
Do we have to over-exaggerate?
All right. So,
Do we have to over-exaggerate the 20 more boys?
yes, absolutely. So on the back side of your paper, turn your paper over. We're going to do this pretty fast. Hopefully the idea is that we'll do two rounds of 20, I think there's 22 of us in this class, 21, of 21 trials each. Josh isn't here, so I think there's 21. So,
Josh threw up this morning. It was gross.
okay, so.
He was gross.
Sorry. You have to make a prediction out loud of what you think it is, and you reach in the bucket and pull it out. We'll go this way first, and then the second round we'll go backwards. And I'll tell you what it is so you can keep track of what is pulled, because that's what you're doing. It is yellow, blue, or red.
It's Hubba Bubba.
She says yellow, and it is blue.
Ooh.
Write down blue. Write it down.
Let's go red.
Oh, so I got yellow.
Red.
No predictions. Just make them individual. Up. Blue. What's your prediction?
Yeah, that's right.
Scarlett says red. She gets blue.
There's a lot of blues and yellows.
She says yellow. And it is blue.
Definitely gonna get blue next time.
Alright.
He says red.
Rigged.
Oh, and it is
It is rigged. Yeah, I don't think you're.
blue. She says blue. And it is red. Ryan says yellow. It is blue. Vanessa says red. It is blue.
The only time it's not blue, they guess blue.
Chris says blue. And it is red.
These are color changing cubes.
Voice, because you know a school can afford voice command color changing cubes. Absolutely. We would buy those before really anything else. Presley says blue. Presley is correct. Ben goes yellow and he gets red.
I'm sad inside. I failed to win.
Cody said blue and he got blue.
Go, Cody!
Madonna's going for yellow, but she got blue.
Blue. Everyone's saying
Denise goes red. She gets red.
dang. Finally.
Blue? And it is blue.
It's red.
Carl says yellow.
It is.
And it is blue. Anthony says,
Particle man. Particle man.
oh, he said blue and it was yellow. Red and it was red. Last one. Blue and it's red. All right. So this is what I'd like you to do. Draw a line just underneath that data. And you're going to need your calculator here for sure. Talk to your team, and I want you to calculate the probability of pulling a certain color out based on our experimental inquiry on round 1. So your job is, I don't know, you're going to have to count. I think it's 21. 20. All right, 20 trials, sorry. So when Josh is here, it's 21. 20 trials. Figure out the probability. Go. Work as a team.
Do I now have a calculator bag?
You should. Yeah, all 3.
Oh, I haven't seen it at all.
It's around there somewhere.
Yellow was 6 divided by 21. Antoine, it's 25. It's
All right. So, we know there were 20 trials. That's what kids counted last time, right? 20 trials. All right. How many times did we pull blue? 12? So that is a 12 out of... That's a 12 out of 20 fraction. What about red? 6? 6 out of 20. One was yellow? Right. Whoops. All right. So our learning target was I can predict with accuracy using probability. So now, if you were to predict next round, we were to draw another 20, right? 20 trials, another 20 blocks. what do you think your results will be?
I mean, obviously not the exact same.
There's gonna be more yellow.
Okay, Carl's saying more yellow and red. Why, Carl? Why are you saying that?
Because there's not. Yeah, it's.
No, same cubes.
Are you sure?
Yeah.
Don't know that. It's a color change.
He'll look like the cubes.
That was great.
They're gonna be tuning pretty soon.
All right. So you can use probability. What is the one piece that you're really missing that would really, really help you?
Another color.
Radana.
How many of a certain color box there are?
Aha. That's kind of what we're missing, right? We're missing how many of each color are actually in here. So can we use those results to kind of get an idea?
Do we know the total amount of blocks?
Because tell me, is this game totally random?
Yeah.
Okay, it is 100% random. But based on it being random, do we kind of know what colors should come up more?
Yeah.
Interesting. So we believe we have a random game, but we know there's more blue cubes, less yellow, and more red, according to our results. Interesting. All right, here we go. You got that line across, right? All right, here we go. Allie. Shh. She says blue, and it's blue.
Oh, I don't know.
Only gets blue.
Going blue.
He's going blue, and he got blue.
Are you gonna tell us?
He says yellow, blue.
Red.
He says red, and he got red. Yellow, red.
Yeah, blue.
Blue again, and it is blue. Nice.
What are you guessing?
It's right there. Blue.
She says blue, blue.
Yellow.
Oh,
No.
Only guess blue.
What was it?
it was a blue.
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 He says blue, and it is red.
This makes sense.
I'm gonna go with blue.
Blue, and he got a blue.
Yeah.
She says blue, red.
Yellow.
She says yellow, red. He says pink, and it was red.
I'm gonna say yellow.
Yellow, blue. Blue, red.
Yellow.
Yellow, yellow. And she guessed yellow. Blue.
Let's go.
Yellow. Blue.
Yellow.
Yellow. Can you?
Yellow.
Yellow. Wow.
Be blue. Be blue. Blue.
Red and red. All right. So go ahead. Shh. I want you to calculate. Listen. Hey guys, calculate the experimental probability for each one of the colors second round as well. Go.
At least it was shut.
You guys gave me an extra one last time. Remember I had to write and you guys gave me an extra one? There's 20 times 5. It's just like the adding.
Sounds like a weird cheer. That's just like how many yards you have in the course of the game. So then,
How many reds did you get for the Yes. Like 50%? No. Yellow is actually clear and then blue.
All right. So, okay, let's look up here. So, using the probability that we're getting, we're able to make better judgments on what is going to happen. What was kind of interesting, Radana was the only one who picked yellow coming forward this way until we got over to Cy and Quinn. And by then, we had drawn 17 times and hadn't gotten to yellow. And so probability tells us it is bound to happen. First round, we got it twice. It's going to happen. It will. Is it random? Yes. But are we getting more and more certain that it will happen? Yes. Are we 100% certain it will happen on this one? No. But we know that according to probability, it will happen. So although it's a random game, when you're given more and more data, you're able to make better and better judgments. So this is interesting. So we have a 55% average here. We have a 35% average here. And we have a 10% average there. Now, this is what's, if I were to tell you, hey, there are 100 blocks in the bucket.
Okay.
How many are blue? This is the math you would do. You'd go 100 times 55%, which as a decimal is 0.55, and that would equal 55 blue blocks. So if I had 100 blocks, 100 times 0.55 is 55. So that means out of the 100, 55 are blue. If I was to tell you, hey, I actually don't have 100 blocks, I have 80 blocks. 80 blocks in there, so you'd go 80 times 0.35. 28 blocks. That means if I have 80 blocks, 28 of them are red. So what happens if I said I have 60 blocks? Figure this out with your team. How many would be yellow? Go.
6.
Of course. So 60 times 10%, 10% is 0.1, that equals 6. So if I had 60 blocks, 6 are going to be yellow. So this is the cool thing. I want you guys to try to figure this. This is neat. We have 18 blocks. That's how many are in the bucket. So, how many should be blue? How many should be red? How many should be yellow? Go. We have 18. You should be, hey, this math, guys, should be on your paper. You should be doing it. We have 18 blocks.
Would it blue be 50%?
No. Well, this one was 50, but that was 60. So we averaged.
doesn't really work.
What is this? 6?
6.3.
That's 6.3. This is 1.8. Is that 10?
Yes.
10 point what?
10.
Even?
Yeah.
Oh, it's by 5. Of course it is. Okay. So, according to our, how many trials did we do?
20.
No,
40.
we did 40. We did 40 trials. We did 20 up here, 20 here, 40 trials total. So according to our 40 trials, if I said, hey, there are 18 blocks in there, well, 18.55, which is 55%, that would mean 10 of them should be blue. 18 times 0.35, 6.3, which we'd round down, we'd say 6. This is 18 times 0.1 is 1.8, we'd round up, we'd say 2. Okay, this is a completely random game, right? I mean, all we did was just reach in and draw and pull out. You guys, that is exactly how many blocks are in here. There are 10 blue, there are 6 red, and there are 2 yellow. So, is it random? Not really, is it? When is it hold on. When is it random?
When you're choosing.
When you're choosing. When you actually reach in and pull it out. But when I look at data over time, is it random? No. Probability takes over. That's why you're not allowed to go to Vegas and count cards. Because probability wins every time. It's how it works out. There was a guy in Vegas, and this story is, I don't know, from a couple years ago. He went to, you guys know the roulette table?
Yeah.
So he got busted. But he was working for another group of people. But they had like micro cameras like on their lapel pens, and they were and a number of them came to and they tried to figure out, how did this guy know this was going to happen? Well, he had so many people, and they would constantly go in and out from the roulette table. You guys know roulette? Yeah. It's you spin the big circle thing, and there are 52 numbers, okay? So with one ball. So your chances of getting a number are 1 in 52. Okay, and then there's black and red. And black and red alternate. So you have a 50% chance to get red, 50% chance to get black. And they alternate on the table. Well, they'd been watching, this guy's an idiot savant, same thing. They had been streaming for basically an entire day, the roulette table. And on 2 wins, he was able to predict a 1 in 52 chance, which pays out at like, if you put $1, it pays out like $700 if you get it right.
What?
Okay? But they put down a lot of money because he was like, I'm within like an 85% accurate, because he's keeping track of everything, and he nailed it twice, and they end up winning something like over $1 million on 2 roulette turns. And then they end up getting caught because they were like, this doesn't happen? Because they do their own math. What's the probability of it happening is like beyond extreme. It's like winning the mega bucks or mega lotto or whatever. So anyway, they figured out that this guy must have been counting, and they went back and they looked and they researched, and then that's when they found out, like, wait a minute, that guy's suspicious, he's suspicious, and then they end up getting busted. But they literally did probability, because sooner or later it will win. All right.
Hey, can I interrupt just for a second?
Yes.
You guys, this is a common question that you're going to see, and we were just doing a calc review for tests. So you're often going to see the word 55% of, and you're going to say, a question might be, what's 45% of 19? Now you're going to know how to set it up. So when it's what percentage of, you know it's multiplication. That word of means multiplication. So you have to change that percent to a decimal, and whatever number they want to know of, you set it up like this. So how would you guys say how we did this one? But using of.
55% of 100.
Right, and how would you do this one?
35% of 80.
Okay, you're gonna see that a lot, so you wanna set it up just like this.
Oh, that's so good.
Yes.
Yeah, that of is that's something that we had a hard time with in comparing and scaling right at the beginning. All right. Any questions about that? That is cool. That worked out. That's the first time it worked out dead on perfect.
We should watch the rest of the video. I want to see the rest of
Okay.
Polygon.
Scott.
My bird is missing. That's hilarious.
Okay. All right.
My man's out here.
I predict the block will be blue.
Now it's your turn. What do you predict the color of your block will be?
There you go.
Duh.
So,
3 seconds left. I want to go first. I want to go
no, you definitely want to go last with probability, right? Because you get to see what's getting pulled. And just like Quinn and Cy, we knew a yellow would come up at some point, and they end up coming up at the end. Because probability took over, and it was just bound to happen sooner or later. All right.
Let's go get a Chuck E. Cheese and waste
Now you want to go gamble, huh? All right. So we have this is what I'd like you to do. We've already completed A1, A2, B1, B2. So your job is to start on C1 through C4. We're going to start right here tomorrow. So go ahead, work on it independently. It's on page 29, 2.1, and it is C1 through C4.
Wait, work on this paper. Yeah.
Yeah, work on the 2.1 you grabbed. See you, Chris.
It's on page 29.
Page 29, yep. C1 through C4.
Mr. Cohen, I think your clock didn't get set right.
Yeah, I don't have yet.
It confused me earlier too. I was like, wait.
You're an hour early.
Yeah.
Don't you guys want to stay here for another hour?
No.
I almost went back to special. I would rather do that than me.
Actually,
I just kind of go through my day without looking at the
I didn't fix my phone yet.
Actually, I look at the minute hand for every clock. That's the only
Okay, guys, if you can go ahead, put that away. Get your warm up and exit out. So, your warm up and exit We have problems 1 and problem 2. 1 and 2. It's on page 36. So we were talking about I can predict with accuracy if I have chances to win. Yes, you can do that using probability. We've talked about examples of guys counting cards. We just showed you a perfect example of randomly pulling cubes out. And it came out to be perfect after 40 trials, and we got data that was spot on. Completely random, but yet over time you can see a pattern and use probability to make a good prediction.
How close was first and third?
They were 11, and they had 6 for the red, but 11 blues and 1 yellow. And I think that was the same for 6. 11 blues, 6 red, 1 yellow. So, I mean, they were really close, too. Yeah, I mean, really just 7th hour. I mean, come on. I mean. So, explain what happens, and there's not necessarily one right answer here. You can have a couple right answers, for sure. Explain what happens to experimental probability as you do more trials. So that's experimental probability right here. This is experimental probability. Theoretical probability is this, is reds, well, we had 10 out of 18. Here we have 6 out of 18. And here we had 2 out of 18. Uh-huh. No, 1 in 52 chance is like 2%.
Well, no, but with the color, that
Oh,
a 1 in 104 chance.
it's crazy. And yeah, but probability over time, Ben, it's bound to happen.
It stays there for some.
Pretty amazing. So what did we get for Jaden? What did you write down for your answer here? Explain what happens to experimental probability as we do more trials.
I wrote you can say that from the same thing. If you keep on doing more to get an answer.
You'll get more and more data, and your data will be more and more accurate. The more you do it, the more accurate it'll get. And another answer, yeah.
I said for mine that you can, that you have like more of a better prediction of like what your result.
Yeah, the more trials, the better prediction. And that's what those guys are doing, right? When they're counting, they're just getting more and more accurate. Radana.
As you do more trials, the experimental probability becomes more accurate because you can begin to tell the amount of cubes for each color, and the percents will begin to help show that.
So
Yep.
in the roulette, there's only 52 numbers, right?
Yeah, but there's red and black.
Yeah, but there's also red, black, and cards, and there's only 52 cards in a deck.
Mm-hmm.
So that would
You have
really
the same chance of landing on your number as you would pulling your number out of the deck.
Pretty much. Yes, Ben.
I said that the experimental probability gets closer to the theoretical probability.
That'd be another answer. Okay, calculators, please put them back in your toolkits. Say, I think something fell out of yours. Can you put your calculator back?
Yeah.
And we'll see you guys later.
Any